Okay, here we are with the 2017 AP number 3. It's a non-calculator question, which means we cannot use our calculator, hence the non-calculator nature of the question. And the question starts out with a function. They give me a graph of f prime. That's going to be key. I'm not looking at the problem yet, but I know f prime is the values. So, Michael, what does it mean are the slopes of this graph? That's right, Michael, f double prime. And Michael, the integral of f prime, sorry, f is going to be the integral of f prime, which is going to be the area. I don't know if they're going to ask me about any of that stuff, but I can see I've got my shapes here listed to go. So I'm going to read my part of my question. My calculator doesn't need to be here, because he is not a calculator question. There we go. The function f is differentiable on the closed interval -6 to 5 and satisfies the one condition. There's always going to be a point I need. So the point x equals -2, y equals, however you want to think about it, 7, is on the graph of f. The graph of f prime consists of a semicircle, 3 line segments as shown in the figure above. I guess I'm going to find areas of those and have to figure things out about it. First it says find the values of f of 6 and f of 5. Yes, who said 6? F of -6 and f of 5. So to find information about f, I'm going to find the area under the curve. I'm going to find it for all the regions, and then I'll adjust from there. Okay, so this is a half a circle whose radius, color here. Whoa, I just got a crayon. Crayon's not going to work for this, be my guess. Pen, red. Okay. So I'm going to figure out this region first. Okay, and now I'm working with a crayon, obviously. Okay, I have a half of a circle, and the radius of that circle is 2. So the area of the whole circle will be pi r squared, which would be 4 pi. Because it's half a circle, this region is 2 pi. I'm not assigning plus or minus signs to it yet. I'm going to deal with that when I'm done. So the next thing I've got is this big triangle over here, which is going to be 1/2 the base times the height. The base is 1, 2, 3, 4. The height is 1, 2. So this one is 4. And then I'm going to come to this next part right here. I've got a triangle. 1/2. The base is 1, 2, 3. The height is 2. 3 times 2 is 3. Okay, there was a small glitch in recording. Michael leaned on the record button. So Michael, be a little more careful next time. Thanks, buddy. So they want me to find f of -6 and f of 5. Now, there's equations we can do with. I prefer to do this using common sense. I'm going to write down, I already know that when x is -2, I know that y is 7. And they want me to find values at -6 and at 5. Okay. So all I got to do to find where the values are is figure out how much more area is under the curve, because that's going to tell me where my x ended up going to. So they want how far. I'm going to do the positive value first. If I start at -2 and I go up to the number 5, I'm going to cover this total distance right here. Well, how much more area did I add? Well, I started at 7. I had 7. I subtracted 2 pi, and I added 3. So that's what f of x is going to be at 5. This is x. This is f of x. And I just got to be careful, because now that I'm doing -6, I'm going to go backwards. So if at -2, here's the distance. I'm going to mark these out. Here's -6 all the way to 2. -2. Who said 2? From -6 to -2, I added 4 units. Okay, so I believe the answer is going to be either 3 or 10, because I'm just adding it on to the combined with the 7 here. I'm going to write down 3 and see if I got it right. If at -6 I'm at 3, and I add 4 more units to the y value, I end up at 7. So that is the correct answer for that part right there. Gonna pause this. The part B, which says on what intervals is f increasing, justify your answer. I look at increasing or decreasing by looking at f prime, the derivative of f. But I got to remember what I have in front of me. f prime are the values of this graph. So I'm going to make a number line graph for f prime and f. So I need to know anywhere where f prime is 0 or undefined. So I need to know anywhere where the value is 0 or undefined. So the value is 0 at -2. And make it a little bigger. Hold on. Erase that there. And the value is also 0 at 2. See anywhere else where the value is 0? Yes, at 5. And now I need to know whether the value is positive, negative, in between. So the value is positive before 2, negative after 2, positive between 2 and 5. That means the graph of f is increasing, decreasing, increasing. Remember, I'm not going to see that information. I'm getting it out of the graph here. On what intervals is f increasing? Justify your answer. F is increasing between, so it starts at -6. Between -6 and -2. And between 2 and 5. You can write those words out. You don't have to do it in the mathematical form. And here's what Ethan likes. He says, justify your answer. You can write C graph and point over here. That's all you need. Your number line graph is full justification. Words are not required once you have a number line graph. If you're a wordy person and you need to put words down there, put more words down there. It's absolutely okay, but you don't need them if you have a number line graph. They ask me to find next the absolute minimum value of the graph of f. Now remember, I have a lot of information here. I have what I know is going on with f in terms of it increasing and decreasing. I have some values for f that I got from the original part, and I'm going to look to see what's going to happen. So I'm going to follow this number line, this graph up here, and just use information I know about f. So I know when f at -6, the function f, let's do this in green. Green. There's green. F is equal to 3. Now remember, area under the curve is f. So as I move from 3 to the next point, which is -2, I'm adding all of this area on. So it goes up to the graph of a value of 7. Then between -2 and 2, the graph goes down. We put this negative area on. When we get to there, we're at 7 minus 2 pi. And then the graph adds more area, so it goes up to 7 minus 2 pi plus 5. So the lowest points in the graph are either the endpoints, either right here, which has a height of 3, or at 2, which is 7 minus 2 pi. I need to know if 7 minus 2 pi is less than 3. Pi is about 3. 3 times 2 is 6. 7 minus 6 is 1. So this is the lowest value. So the lowest value is, I'm going to put both the x and y value down, that way I don't get it wrong, is at 2, 7 minus 2 pi, close parentheses, C graph. That's the information on there I need to find that value. As part of the question, ask me about f double prime. And f double prime related to the information we have. I scroll up. F double prime are the slopes of the graph right here. So the slopes of the graph of f prime equal f double prime. So they want me to find f double prime of -5 and f double prime of 3. So I've got to check the slopes of the graph at each. So the slope at f, I got to erase some of this. The slope of the graph at -5 is the slope of this line right here, which is down 1, 2 over 1, 2, 3, 4. Down 2 over 4. Down 2 over 4. You don't have to simplify. And the slope at 3. Whoa, I've got your window, sorry. The slope at 3. There's a cusp there. So there is no slope at 3. does not exist. No, because a cusp occurs at x equals 3. So this actually sends you an extra need. So f prime is not differentiable. You can't take a derivative at x equals 3. I used way more words than I needed to. I could have just written down f prime is not differentiable, there's a cusp. Or can't take a derivative, there's a cusp. All that would be enough to get you points. Okay, saving it up. I'll get ready for the next one. Take care.